Hello guys, welcome to today's class. Today we'll be looking at differentiation of composite functions, also called function of a function or chain rule. Now, why do we use this function of a function? Is to differentiate um, a, a function that has a greater power. Like when you have a function that has raised power 2, 3, 4, 5, the power is very high, we use function of a function. Now, it's not far-fetched from doing the normal expansion. You still get the same thing. But when you use function of a function to differentiate, it will ease your stress and it will save you a lot of time. Now, for example, let's see this example. Find the derivative of x squared plus 1 all raised to power 4. You can as well say x squared plus 1 times x squared plus 1 times x squared plus 1 times x squared plus 1. So when you expand, you open the bracket, then you differentiate. But this is time consuming. So I think function of a function will help us to save a lot of time. Now, doing function of a function, also called chain rule, we say that dy over dx is equals to dy over du times du over dx. So by the time you cancel out du, you go back to dy, dx. So what we're trying to do, we're trying to expand. Okay, we're trying to expand the y dx, which is same thing as, that's why we call this chain rule. Now, if the function is x squared plus 1 all raised to power 4, we can say y equals to x squared plus 1 all raised to power 4. Now, let's find the y du. Before we find the y du, we'll let our u be equals to x squared plus 1. Now, if u is this, so we can find the u over dx. So that means we're differentiating u with respect to x. We do that here, I'm going to get 2x. So, but if u is x squared plus 1, that means y equals to u raised to power 4. So if we represent our u as x squared plus 1, we get y equals to u raised to power 4. So that means we can differentiate y with respect to u, which is dy over du, and this will give us 4u raised to power 3. Okay, now we have our du over dx, which is this. We have our dy over du, which is this. So we can actually multiply. Going by the formula, we have dy over dx equals to dy over du times du over dx. Now I have dy over dx is equals to dy over du, of course, is 4u raised to power 3 times du over dx, which is 2x. So we have dy over dx to be equals to give us 8x u raised to power 3. So we represent our u, put our u back as from the beginning we said let u be x squared plus 1 all raised to power 3. And this is our dy over dx. Okay, this will save a lot of time for you. So if you expand the other expansion, it will take a lot of time, but you still arrive at the same answer. If you like this video, please subscribe to my YouTube channel, Calculus 360, share, like, and comment. Thank you.